Okay, so we're back here with American Miscellany. I'd love to get through our next essay here, essay number 93, Lectures on Astronomy, but it is number 5 of these essays. And at this point, I think we all know how long-winded and boring and rather pompous Professor C.M. Mitchell is. But you know what? It's okay. We've got to give him a fair chance. You know, he published in this crazy book, this book called American Miscellany, published in 1865, which is just a collection of essays that hopefully are historic and scientific, but I don't know, sometimes are neither. But we'll see. Let's see what Professor C.M. Mitchell has to say. We've just finished a long memoir of Louis Philippe. That was essay number 92. We are now on page 232. And we're on essay number 93, Lectures on Astronomy, number 5. If it were possible for me to transport you to the distance of 90 millions of miles in a direction passing through the sun's annual track, and could there locate you, your sight would in a short time be greeted with a most wonderful and sublime exhibition. You would see approaching you a magnificent world, rapidly whirling upon its own axis. Around this vast central orb you would find a number of beautiful rings of light. These too would be seen to be whirling around with a surprising velocity. On the outside of this again you would mark, as the object approached nearer and nearer, no less than 7 subordinate worlds sweeping around the great central orb, and with it rolling through space. This is the planet Saturn, with its rings and moons, and it is to this object I propose primarily to call your attention. It is the most distant of all the planets. It is the most distant of all the old planets known to the ancients. Its period is the longest, and its movement is the slowest and most majestic. Up to the time of the discovery of the telescope, the wonderful characteristics which mark this object were unknown. But when Galileo directed his space annihilating tube to its investigation, he announced to the world that he found Saturn to be triple, that there were what he conceived to be 2 globes attached to the main body, one on the right and the other on the left. But these were only the projections of those mighty rings standing oblique to the line of vision, and seen imperfectly through his glass, which magnified but 20 or 30 times. They appeared to him to be projections or globes attached to opposite sides of the main body of the planet. As the telescope was improved, these projections had their true character revealed, and it was seen that a flat annulus, or ring, passed entirely around the globe of the planet and was separated by a certain amount of distance. As the power of the telescope was increased and more minute investigations were made, it was found that the broad ring was divided into 2 rings, and in modern times, within the last few years, by the aid of the mighty telescopes now engaged in astronomical investigations, it has been ascertained that the outer of these rings is again divided, and there is no less than 3 which encircle the planet. The satellites were not discovered till long after the time of Galileo. In the year 1655, we learn, one of them was seen, and shortly after 4 more were announced. Then Sir William Herschel, with his 40-foot reflector, detects the 2 minute bodies that seem to cling closely to the edge of the ring and are scarcely ever visible in consequence of the intense light thrown out by the planet. Here, then, we have 3 rings and 7 satellites, or moons, which belong to this most wonderful sphere. And remember that all these are sweeping with the planet through space, and as it wheels its circle about the sun, they move regularly with it, obedient entirely to its control. But what are these mighty rings? The exterior diameter of the outer one is no less than 177,800 miles. Their breadth, measured entirely across both rings, is 30,000 miles, and their thickness is 100 miles. How strangely are they constituted! How wonderfully are they poised in space! We can understand the original movement of all the planets with the exception of Saturn. We can form some idea how this Earth, which we know to be globular, might have been projected by the hand of omnipotence and caused to revolve in its orbit about the sun. But how was it that these stupendous rings were hurled in such a manner as to acquire that stability of movement which holds them steady to the action of the central planet and at the same time rolls them onward through space with the immense velocity with which they move? This portion of our system baffles all conjecture. It rises entirely above the comprehension of the human mind. While we make some rough approximation to the notion as to how the other planets might have been launched in space, we can form no conception of the manner in which this one was started in its career. But what are these mighty rings? Are they merely a mass of light? Are they projections of the atmosphere belonging to the planet? Are they portions flung out by the centrifugal force and thus in some sense hold steady in their position? Are they solid bodies? I answer, they are solid bodies, and of the same material that composes the body of the planet. But how do we know this? In the first place, we know them to be solid because as the planet with its rings passes between us and distant groups of stars, such stars are first occulted by these, probably occluded, but are first occulted by these rings. In the next place, they are not transparent in any degree because of the fact at that distance of 900 millions of miles, we are able to mark the space of the shadows cast by these rings on the body of the planet. Night after night, month after month, and now almost year after year, have I watched with my own eyes the phases of these wonderful shadows. They are deep and dark, much blacker than any shadow you find cast upon the surface of the earth. But again, they are able to exhibit the same characteristics themselves, and in certain positions we find the light of the sun falling upon the body of the planet, which casts a shadow upon the broad surface of these rings. And though we have the same blackness as before, here is the distinct shadow cast by the planet upon the ring. Now, as we watch them attentively, we find invariably that these shadows depend on the position of the sun and certain positions of the planet and rings. Just as the shadows which are cast upon the surface of the earth depend upon the position of the source of light, so do these, and they follow with the same precision and accuracy the movement of the source of light that shadows do upon the earth, and hence we cannot be deceived. The space by which the interior ring is separated from the body of the planet is no less than 20,000 miles, and the breadth of the ring is about 10,000 miles before we reach that space which separates it from the next ring, and so onward till we pass the outer one, of which I have just spoken. Now, how is it that these rings are held stable? How is it that they, detached from the body of the planet, are carried with that planet through space? The stability of the rings of Saturn is perhaps one of the most difficult and perplexing problems for the astronomer, and I would do injustice to the subject were I to pass over it without attempting to give some notions of this singular problem. And before I begin, permit me to explain the fact that there are three different kinds of equilibrium, for in the understanding of this will be involved the understanding of the explanation which I am about to make. I will attempt to exhibit these three different kinds of equilibrium by the simplest possible explanation. If I were to If I were to suspend a rod from the top and cause it to vibrate as a pendulum, it would finally stop of itself. Here is an equilibrium of stability. Why? Because if I move it ever so little to the right or left, it will come back to its original position. Now, if I take the same rod and balance it horizontally across my finger, it being equal in magnitude and density throughout, I have an equilibrium of inertia, because if I move it slightly, it will not return, but remain wherever I place it. Now there is a third kind, exemplified by taking the same rod and poising it upon my finger so long as I can hold the center of gravity above the point of support. I hold it steady. But the slightest inclination to either side destroys the stability. This is an equilibrium of instability. In consequence of the fact that every deviation tends to increase itself and therefore destroy the equilibrium entirely. Having explained the three kinds of equilibrium, let us now, if you please, pass to the examination of the system of rings of Saturn. It is found by close investigation that in case these rings are precisely circular, in case they are equal in density throughout, in case their center of gravity is their center of figure, and in case we add to this the fact that the center shall coincide with the center of the planet about which they are placed, then the equilibrium is one of instability. And with the slightest cause that comes in to derange the system, such derangement will go on increasing itself, and the center of gravity of the ring will commence moving in a spiral line about the central planet, the ring approaching closer and closer to that body, till finally it is precipitated upon the planet, and the whole structure is destroyed. On our examination of the ring, we find it to be circular, and in the early examination, it was believed that the center of gravity was coincident with the center of the figure of the ring, and moreover, that the center of gravity of the figure coincided with the center of the planet. This being supposed to be the fact, it is impossible that this system should be perpetual, in case there was found in the satellites which revolve upon the exterior a disturbing influence sufficient to draw this center slightly away, and thus begin that very kind of motion which must end in final destruction. It was not till after Laplace gave his mighty intellect to the solution of this problem that the truth was discovered. He found that the stability could not be guaranteed in any other way than by making the ring unequally thick in different parts, or at least of a different specific gravity. This was not all. It was necessary to move the center of gravity from the center of gravity of the planet and cause it to revolve about that center in a minute orbit. Yet, however strange this might appear, it seemed as if Saturn was too remote for the telescope ever to verify the principle of this extraordinary statement. But it happens, fortunately for the system, these rings, which are so very thin, are occupying a position such that the eye is situated in the plane of the ring, and we see them edgewise. And when we view them in the first place, they exhibit the appearance of a line of light drawn across the diameter of the planet passing through the center. Now, in the disappearance of the ring, by its taking up this position, we are enabled to examine with utmost possible accuracy, and it has been found that the two extremities do not disappear at the same time, and that there are inequalities upon their surface which are well marked and defined. The very thing precisely that Laplace predicted would be the case, provided an instrument should be found of sufficient power to discover them to the eye. But this was not all. The most delicate micrometrical apparatuses were constructed, and with these, which were capable of measuring the most minute distances, the space between the planet and the ring upon the right and left were determined. And it was discovered that these spaces were unequal, not only unequal but variable, and not only variable but changing according to a certain law. Thus, it was shown conclusively and absolutely that the center of the planet did not occupy the center of the ring, thus bringing in the other condition requisite for stability and fastening the whole system permanently in space. Now, how could these rings have been formed? It is possible that they were attached to the planet after it commenced its journey. Is it possible that they were attached to the planet after it commenced its journey in space? It seems impossible for us to conceive how this might be accomplished. Hence, some philosophers have adopted the idea that they were formed at the same time with the planet and by the action of the same law. And in all probability, the celebrated nebular theory of the formation of the universe derived more support from the exhibition of Saturn's system than from all other causes combined. It was supposed that in the beginning of all things, the matter which now forms the sun and planets and satellites was diffused throughout all space, or if not throughout all space, at least to a vast distance from the place which the sun now occupies, and that this inchoate matter was divided and its particles held asunder by the repulsive power belonging to it. Laplace conceives that in the process of time, under the action of gravity, the mass of particles commence a movement toward a center, and in coming from positions diametrically opposite, they pass each other, and thus a rotation is commenced about an axis. When millions of years shall have rolled away, and when this mighty sea of crude matter shall have been slowly impregnated with gravity, and consequently with motion, it will contract, and as it contracts, its velocity of rotation must increase, till finally the centrifugal force generated at the equator of the revolving mass overcomes the force of gravity, and a flat portion is detached from it in the form of a ring. When this has been once loosened and detached, after millions of years shall have rolled round, we find the central mass contracting and leaving this ring in space, revolving with the velocity due to the revolving mass at the time it was detached. Now then, in the process of the formation of the planet, this ring may possibly break up and coalesce into one mass. The same cause which operated in the outset to detach the ring from the mass will in the second instance detach from its equator other masses which may form satellites, or these by possibility may even remain and become solid in the form in which they were first thrown off. If we admit this wonderful and strange theory, we can understand how it was that the mysterious system of Saturn existed, and how the conditions of stability were such as they now are, and how it is that this body moves on century after century without any changes, with the stability which fastens every part of it forever permanent. I do not pretend that this is the manner in which this system was formed. I do not know, I cannot fathom any such mysterious problem. But one thing, however, I do know, and that is this: that if by the application of the higher powers of analysis this most extraordinary theory is demonstrated to be true, it carries the mind higher and nearer to the great source of all things than any other which the human intellect has ever derived. Than any other which the human intellect has ever devised. It gives a more comprehensive idea to the omniscience and omnipotence of God than any other theory of which I have any conception. For here, with matter in a chaotic form and scattered throughout all space, having been brought into existence by the fist of his will, by the action of one solitary law, the universe, as boundless as himself, is upheld and sustained forever. We pass on from the examination of this subject to another. If in the planet Saturn it seems as if the analogy by which the system is governed has been broken, we shall find in the next planet, which revolves upon the exterior of this, a still more strange anomaly. For a long time there were certain difficulties with regard to the movements of Saturn, which seemed to perplex philosophers. It was getting out of its computed place, and the most extraordinary difference was seen in the movements of Jupiter when compared with those of Saturn. It was found that during the whole of the 17th century, one of these planets was perpetually getting behind in its computed place, while the other was getting in advance. It seemed that the two were moving in some way in which one was dependent upon the other, and it was next to impossible to discover how it was to be made out. Finally, the problem was taken up by Laplace and solved, and the explanation is perhaps as curious as any which has ever been presented for the examination of the human mind. Who would suppose that the stability of our system depends in any degree upon the relation existing between the periodic time of the planets? Yet this is the fact. We find that in case the periodic times of any two planets should happen to be in such a relation to each other that one of them taken a certain number of times should be equal to the other taken a certain number of times different from the first, then irregularities would be introduced in the system, which would go on always increasing in the same direction, and the equilibrium would be that of instability. Now it happens in the periodic times of Jupiter and Saturn that there is a close proximity to such a relation, 5 periods of Jupiter being about 60 years and 2 periods of Saturn about the same time. Now suppose tonight Jupiter and Saturn occupy a given position with reference to the Sun, and they start out on their career. At the end of 60 years, they will come round again to occupy almost exactly the same relative position. And whatever effect Jupiter might have had to hasten the movement of Saturn, or Saturn to retard that of Jupiter, will again be repeated in the same way and in the same position, without the possibility of restoration, except with a difference of configuration on the opposite side. Strange as it may appear, this particular case comes very nearly, though not quite exactly, to that of these planets. Yet they do not reach the same position by an amount equal to something like 6 or 7 out of the 360 degrees. Here they are a little behind at the succeeding year. At the next, still further. At the next, they have changed yet again, till now, after about 2,500 years, they come on to occupy the first position in all the successive rounds of their orbits, and not till they have gone entirely around will the compensation be effected and the system be restored to its original condition. Such is what is called the long equation of Jupiter and Saturn. I do not mean to say the period is 2,500 years, because in consequence of the fact that they come to resume the same relative places in different parts of their orbits in the same they come to resume the same relative places in different parts of their orbits, the same will be effected in a shorter time. And indeed, in consequence of this difference of configuration in different parts of their orbits, it is accomplished in 900 years. It appears then that this particular case, which seemed to set the law of gravitation at defiance, is reduced absolutely within the control of the law, and a most beautiful explanation of the phenomena is presented. When these difficulties had been removed, a more rigid scrutiny seemed to reveal others in Saturn, till finally, after having exhausted all the means within the limits of the solar system to account for them, some mind ventured to pass the limits that had hitherto circumscribed it, and say, there must be a planet upon the outside. But no one dared at that time to undertake the resolution of the vast problem by whose solution the position of the unknown body could be determined. Fortunately for the world, in 1781, Sir William Herschel, in one of his telescopic explorations, found an object which attracted his attention. In short, he saw in it something which resembled a planetary disk. On the following night, the examination showed that body to have changed its place. Yet so little did he expect to find another planet that he announced he had found a comet and commenced to compute its orbit, but found no elongated orbit would suit the place which had been given to it, and that nothing but the circular, or very nearly so, would fulfill its conditions. It was found to be a planet revolving outside Saturn at a distance of 1,800 millions of miles from the Sun. This, first called Georgium Sidus in honor of King George III, is known by the name of Herschel. That's kind of cool. More generally called Uranus. In the course of 5 or 6 years, Herschel announced he had found 6 satellites revolving about the body. But what astonishment every one was the announcement that these satellites, instead of following the analogy of the other known planets by revolving in the same direction in which the planets moved, were actually moving backwards in their orbits and nearly perpendicular to the plane of the ecliptic. Here was a difficulty in the great system of the universe called Laplace's theory, which I have already announced. If this system was formed as he supposed, how is it possible to account for the retrograde motion of these satellites, and for the fact that their planes are nearly perpendicular to the plane of the ecliptic? Perhaps it is impossible to account for it, but if we will admit that such a thing may occur as the impinging of a comet upon any body in our system, it would not be impossible to account for those retrograde movements, nor for this great inclination, by supposing at the time this was a fluid mass. The movement may have changed its rotation upon its axis, and have caused the satellites to take the position they now occupy. I do not present this for anyone to receive as a true hypothesis. It only shows that those who adhere to a particular theory will find ways and means of explaining difficulties which others would never think of. Neither do I wish to be understood. Neither do I wish to be understood as having adopted Laplace's theory. Very far from it. It remains to be demonstrated yet, and is possible the means may yet be attained whereby, by the power of analysis, we may bring out the truth or falsehood of this most stupendous theory. We are obliged, therefore, to accept the statement of Herschel for the present, although, so far as I know, up to the present time, no eye has ever seen more than 3 out of the 6 satellites which he tells us revolve about this planet. When this planet had been watched a sufficient number of years, and the observations had been made by means of which its orbit could be computed with accuracy, and the place which it had occupied years and years before its discovery, on running back through the catalogues of stars which had been formed by preceding astronomers, it was found that this body had been seen a number of times and had had its place fixed in the heavens, being regarded as a fixed star. These early observations were of infinite value in determining a more accurate orbit of this planet, so that long before the elements of this orbit were known, it was possible to predict its position in all coming time. But when these predictions were made and when observation and theory were compared, it was found that the planet was deviating from its computed place. It was found that no analysis could confine it. It has broken away from its computed orbit, and at the distance of 1,800 millions of miles from the center, this body seemed to be moving lawlessly through the heavens. Quick pause. This ripped edge here, I remember coming across a corner earlier, and there it is, right there, page 215. This guy, right? This has to be it. Ah, look at that, so satisfying, right there. That's it. I wonder when that happened, how long ago that happened. Look at the different color, different stains. All right, that's beautiful. All right, in order to resolve this great problem, it would be necessary to go into a minute investigation of all the observations that had been made, to go back from the planet through the whole solar system to the sun itself, and to ascertain with the most perfect precision what influence was exerted by all the known bodies upon this one. If, after every possible influence had been admitted, accounted for, and applied, there were yet outstanding inequalities remaining unaccounted for, it certainly became necessary to look for their cause beyond the limits of the known solar system. This was the problem taken up by Leverrier, and to which I will now call your attention. Perhaps there is no person living in the world who occupies so unfortunate a position as the individual just named. This may sound strangely in your ears. The difficulty is this, that he has accomplished the resolution of one of the most sublime problems ever attacked by the human mind, literally and truly accomplished it, yet that problem turns out not to be the problem of nature, or one that God had given to be resolved. I know how difficult a task it will be to explain this, and it is this particular difficulty which constitutes the truth of what I have stated, that his position is one least to be envied, for he probably never will receive credit due to him, in consequence of the fact that the planet so recently found is not the planet of his analysis. But now for the examination of this matter. Leverrier is a comparatively young man, and had shown the power of his genius by a rigid examination of the conditions involved in the movements of the planet Mercury. He had taken up the old tables which seemed to govern the movements of this planet, and had corrected them from beginning to end. It was believed that the knowledge which they already had of the movements of this body was sufficiently correct for all practical purposes. The transit of that planet across the sun, which occurred not long since, gave the opportunity of testing the accuracy of his investigations in the most perfect manner, and when the results came in from every quarter of the world, and were concentrated at Paris and presented for examination, it was found that he had predicted the instant at which the planet should touch the disk of the sun more accurately than any other person who had attempted it, and indeed he only failed by the amount of 16 seconds of time. His greatest success in this particular induced by his friend Arago to request him to attempt the resolution of the problem of the perturbations of Uranus. He commences not to skim superficially over the surface, taking for granted what had already been done, but going back to the first observation recorded, and traces each and every one down the stream of time, sifting out everything which belongs to each of them. Not satisfied with this, he commences a review of all the planets that can operate upon its motion, and makes a new theory for Saturn and for Jupiter, takes into consideration even the change of position occasioned by the action of Jupiter upon Saturn itself, and the minute subsequent changes in the action of Saturn upon the planet 900 millions of miles distant from it. All these things are gone through, and with the hand of a master he holds the problem steadily before his gaze, and seizes every point with perfect certainty. At length He has accounted for the perturbation due to the actions of any known body in the solar system, and there is a certain amount yet outstanding. And now the grand object is to pass upon the true elements and see whether it be possible so to locate a planet in space that it may account for this outstanding perturbation, and whether by giving to it this position it is possible to find it. How did he attempt this? To most persons, it would seem utterly beyond the grasp of the human intellect. But let us consider. In the first place, Bode's law of distances told him about where it would be located in space. As Saturn was about twice as far from the Sun as Jupiter, and Uranus twice as far as Saturn, he had a right to conclude that possibly the unknown body would be located at twice the distance from the Sun of Uranus, or 3,600 millions of miles. Having obtained the distance, Kepler's law gave him the periodic time, and the velocity became approximately known. But now the great point was to get one particular position, and if that could be obtained, he could follow its progress and tell where it would be at the end of any given time. To accomplish this, he commenced an examination of the derangement in the planet Uranus. He found that in certain parts of its orbit, it is going further and further away from the Sun. Its radius, or direct line to the Sun, was elongating. This, he thought, was no doubt occasioned by the action of a planet. Let us locate the two planets in imagination. Suppose they are on the same side of the Sun. Then the space by which they are separated is but 1,800 millions of miles. But if their position is on opposite sides of the Sun, the distance is increased by the whole diameter of the orbit of Uranus, or 3,600 millions of miles. Then there will be a vast difference between the power exerted in one position from that in the other. Now, if he could not only find a point in which Uranus is drawn furthest from the Sun, if it commences to sweep out and, having passed a certain point, begins to gradually draw in from the point where it was the most drawn out, then in the prolongation of a line from the Sun, passing that perihelion point, must the unknown body be found. All he had to do was to find where Uranus was drawn furthest from the Sun, and looking out in that direction, he locates the body that draws it out. Having therefore found one position and the time when Uranus occupied that position from its known periodic time, he traces up its movement and says at such a day it will occupy such a point in the heavens. He reaches the conclusion of his investigation and presents the results at the Institute of Paris. They are thrown before the scientific world. They are received with incredulity and doubt by the best living astronomers. The problem seems to have been too mighty, too intricate for any mind. But Leverrier desires them to point their telescopes to the positions in which he says the unknown body exists. His request is granted, and lo, to the amazement of the whole world, there is a planet exactly in this place pointed out. There was the triumph complete, and if any had before doubted, those doubts were now removed, and the whole world rang with the praises of the great astronomer Leverrier. And now, as if to make everything doubly sure, it is found that a young man of England had been engaged in investigating the same problem, had reached the same results, and 7 months before Leverrier had published his. He had presented them to the astronomer royal of his own kingdom and the professors of his own university. They, not daring to take the responsibility of uttering them before the world, failed to do it. But so soon as Leverrier's computations were known, so soon as the planet was found, then it became certain that he had been investigating precisely the same problem and reached the same identical results, each confirming the other. And the two combined convinced the world that they had reached the true results. Now, do you think it possible that this is all false? Having carried you to this point, am I obliged to tell you that these computations had nothing whatever to do with the finding of that planet? Yet I am absolutely obliged to do so, for it is true. How then shall I show you and convince you that in announcing this truth I do not pluck a solitary laurel from the brow of this great man? No, not one. There they are, green as in the moment of their winning, and there they must remain forever. As soon as it was known that the planet was discovered, telescopes were directed from every part of the world to its scrutiny. Its movements were followed with the most intense anxiety for the purpose of ascertaining how nearly the real coincided with the computed elements. Adams led the way, as he had done before, in the computation of elements derived from theory, and when he reached to the knowledge of the actual distance of the discovered planet, he was the first who found and announced that hitherto the discrepancy between the distance now absolutely known and the first computation of the distance amounted to almost 3 times the distance of the Earth from the Sun. He had found by computation before the discovery that at the time of the discovery it ought to be 33 times the distance of the Earth from the Sun, whereas it was but 30 times. This did not appear to be a very great discrepancy, yet it was more than was anticipated, for it had been an error of 3 times the distance of the Earth on the opposite side. There would have been more reason in it, because it would have coincided more nearly with the distance revealed by the law of Bode. It seemed, in consequence of the fact that it had fallen on the inside, in some sense to have violated this law. But again, more time rolls on, and better observations are obtained. Finally, there seemed to be no data to commence a computation of the orbit that should reveal what the phases of the planet were in years past and gone, as well as what they will be when hundreds of years shall have rolled round. One of our countrymen engaged in this investigation with ardor, zeal, and success, Walker, of the United States Coast Survey, obtained an orbit and thought he could trace the motion of the planet backwards for 100 years. In tracing it backward, he hoped to find in the catalogue of the fixed stars some one that might have been observed which should prove to be the planet, and thus give us the advantage of a long series of observations extending over many years. The later catalogues were examined. He went back 50 years, till finally he took up the catalogues of Lalande, made in Paris. He found the stars recorded by him, computed the reach through which he knew the planet to have followed at that date, till he discovered that on the 10th of May, 1795, Lalande had observed a star which then occupied a place where he computed the new planet should have followed at that date. But how could he verify this prediction that this was the place, and Lalande had seen the planet at that very date? He turned his telescope to the region in the heavens which Lalande's star had filled, and if it were a fixed star, it would be found there, but it should turn out to be a planet, then would that spot be blank. The telescope was directed, and lo, the spot was blank. Thus it was believed that this was the place of the planet, but when this place was taken into account, and when this observation was combined with later ones, behold, the orbit determined for this new body and the periodic time fell entirely beyond the limits of Leverrier's and Adams' computations, who had announced it could not be a period shorter than 210 years, nor longer than 208 years. Here was a great discrepancy, so that it was impossible that this could be the planet of their theory, in case these observations could be sustained. And now it was that every eye was at once directed to the catalogue of Lalande, to see what his observations were, and distinguished as to what observations were marked doubtful. There were discovered 2 little dots placed opposite this observation, and referring to his preface, dots. It was found that the observations marked with dots were not to be relied upon. Those who longed to find the grand theory that had been built by Leverrier to be true hoped in this mark to find that which would save the system. So soon as a knowledge of this fact came to the Institute of Paris, they appointed an astronomer to review all the old manuscripts of Lalande. It is found that on the night of the 16th of May, 1795, he made this observation and marked it doubtful. On this same identical piece of paper, it is discovered an observation made on the 8th of May on a star which he believes to have been incorrectly made. This he rejects and takes up This he rejects and takes up what he thinks to be the same star, observes it on the 10th, and prints that observation, rejects the other, and marks the printed one doubtful. Now, what a singular state of affairs is here! But the moment the orbit of the planet is computed, that star of the 8th is found to be in the place of our planet, and so instead of having one, we have 2 observations, and the distance between the 2 stars of the 8th and 10th is the same. The planet ought to have traveled upon the hypothesis we have already given. Now there seems to be no doubt left in regard to the fact that Adams and Leverrier stand before the world in different positions from what they had previously occupied, but there is something yet left to be ascertained. There is a planet found in a most wonderful manner, occupying almost precisely the position that their planets, occupying almost precisely the positions their planet did occupy. Is it the planet that accounts for the perturbation of Uranus, or is it not? This is the next question for examination. In order to ascertain that fact, it became necessary to know the mass of the new planet. In the onset, it seemed hopeless to look for an answer to this question for a long period of years, but the scrutinizing gaze was now directed to the heavens. Does not permit the most minute point to escape. At length it is announced that from the distance of 3,000 millions of miles, the light of a little satellite is flung back all the way to the Earth, and that little satellite, by its periodic time around the planet, reveals to us how much matter belongs to this most distant orb. Now, although at present I do not know precisely the amount ascertained, for we have only approximated to it, yet the knowledge we have obtained tells us most certainly and absolutely that no mass can be assigned consistent with the periodic time of this satellite, which will account for the perturbation of Uranus. Hence, the conclusion is forced upon us that this is not the planet of theory, but we have got to look further before we can settle the question as to what produces all the perturbations belonging to this interior planet. Now, can I reconcile my statement or not? Have Leverrier and Adams failed in the problem they undertook to investigate? Have the facts I brought out lowered them in your estimation? I hope not. For I can truly feel for these great men. They had resolved the problem they undertook, they had done it correctly, and in this they displayed the most extraordinary genius that has ever been exhibited by any human mind. But alas, for their fame, the problem they solved was not the problem of nature. God has permitted us to see that And if I were permitted to interpret anything, I would almost say here is a special providence to reward the lofty and powerful efforts of mankind. Such was the structure of the system that it was impossible to attain to a knowledge of it without the solution of this problem. And such was the grandeur of the problem solved, that it deserved as its reward a world, and a world was given. I know you can comprehend this if I bring you back a little and refer to what I have told you the other night with references to the asteroids which sweep around between Mars and Jupiter. Suppose, before these were discovered, some daring genius had undertaken to resolve the mysteries in which the movements of Mars were involved, and they should have reached the conclusion that they were produced by the action of a certain planet located between Jupiter and Mars and at a certain distance, and revolving in a certain period of time. Now here is a problem presented for a solution and worked out with consummate skill. But when the facts come to be known, this problem does not exist in nature, for there are no less than 8 planets revolving in these limits, and combined they produce the same effect that would have been produced by the constructive planet. This is precisely the case in point, and this is the reason why it was impossible for Adams or Leverrier to give the elements of the orbit of the planet now found, for I have no doubt this is only one of more bodies which exist in the same region. Whether we shall ever attain to a knowledge of them or be permitted to feast our eyes on them, it is impossible to know. But a year ago, in the discussion of this subject, when I did not doubt that this was the planet, I ventured to say that, in case it should be found hereafter that the orbit of this planet was not very eccentric, carrying it off to a much greater distance than it now is, and thus accounting for the fact that its distance is less than that assigned by the law of Bode, that it was one of a group. How extended it is impossible to say. I know the difficulties which I have had to encounter. I have tried to impress your minds with one great truth. I do not know how successful I have been, but I cannot close without repeating once again, although this new planet is not the planet of Leverrier and Adams' theory, yet it does not in the smallest degree detract from the just fame which is due to them for the resolutions of this mighty problem.